Hello guys, and welcome back. I'm going to be running through another section A on the micro paper. So you can see here we have an A-level paper, not AS. There will be a mixture of A-level and AS content, but this is a micro paper for the whole Edexcel A-level economics syllabus. So we'll cover a range of questions. So yeah, I'm going to work through each of the questions in section A. Going to provide reasoning for the right ones, the incorrect ones, run through some of the theory, and hopefully you find it useful. So without further ado, we'll get started. So section A, you are advised to spend 30 minutes on this section. Use the data to support your answers where relevant, very important, and you may annotate and include diagrams in your answers. Fantastic. Okay, so the diagram refers to the production possibility frontiers for a country that produces capital and consumer goods. Okay, so we've got a diagram with X, Y, and XZ and various points. Originally, the economy has a production possibility frontier shown by the line X, Y. X, Y, okay, and operating at point V. The production possibility frontier then moves to XZ operating at point U. Okay, XZ operating at point U. Calculate the original and the new opportunity cost of producing 50 capital goods. You're advised to show your working. Okay, so when we are looking at opportunity cost, it's the value of the next best alternative foregone. But in this instance, what we're looking at is if we produce 50 capital goods, what's the cost in terms of the amount of consumer goods we could have produced? So if we start off with the original amount, in order to do this, then I need this figure 120. That is the maximum that I could produce, minus the point at point V, which is 100. And so that is 20. Excuse me, and then the new value is the same thing as 120, and then we end up with 140. So we do 170 minus 140, which gives us a grand total of 30. And that's all you need to do, because it just says calculate the original and new opportunity cost of producing 50 capital goods. So they give you a lot of space, like there's all this space, but you really don't need it to do any of these questions. Which one of the following was the most likely cause of the movement in the production possibility frontier from XY to XZ? Okay, so if we have a PPF and it's talking about capital goods and consumer goods, then usually we're referring to the whole economy. And as a result, what we need to think about is, or similar to what we need to think about, is how we actually improve upon the kind of production possibility of the economy, like the long run aggregate supply curve. So which one of the following was the most likely cause of the movement in the production possibility frontier from XY to XZ? A reduction in unemployment in consumer good industries. If there's unemployment, then there's not an increase in the kind of capital through doing it. So it's unlikely that this is going to be correct. It could be correct, but it's not the most likely. A rise in the cost of producing consumer goods is definitely incorrect. An increase in demand for consumer goods is also incorrect, because we're talking about the production, not the demand. So it must be that the answer is D, a technological improvement in the production of consumer goods. And that's the reason why is because if there's a technological improvement, then there's an improvement in the quality of capital, which will improve the production capability. And that's the reasoning there. Okay, so that is the answer to that question. Explain one characteristic of the economy at position W. Position W. Okay, so here is position W. We're operating within the boundary of the PPF curve. And usually what that indicates is that there is spare capacity, and that might be because, for example, there is unemployment. So one characteristic of the economy at position W is spare capacity. This is likely to be caused by the unemployment being higher than the natural rate. Employment or underutilized resources. Okay, and then that question is done. Okay, so that is the whole of question 1, 5 marks. The number of individual weekly ticket sales from the UK National Lottery games operated by Camelot was 73 million in the financial year 2015-2016. The sale price of each lottery ticket was £2. This figure includes 24 pence of tax revenue on each ticket sold. Calculate the weekly revenue received by Camelot after paying the tax to the government. You're advised to show you're working. Okay, so the number of individual weekly ticket sales from the UK National Lottery games operated by Camelot was 73 million in the financial year 2015 to 2016. So, all right, that's fine. So if we look at the revenue that they make pre-tax, is 73 million, multiplied by 2, which is 146 million. The sale price of each lottery ticket sold was £2. This figure included 24 pence of tax revenue on each ticket sold. Calculate the weekly revenue after paying the tax. Okay, so we need to calculate what the value of the tax was. Now, 24p of £2 is the equivalent of 12p of £1. So what I'm looking for is 12% of this figure. 12% of this figure, because this is the total revenue for weekly ticket sales. So if I do 146 million multiplied by 0. What did we say it was? 12%, 0.88. That will give me what the revenue is after the tax, because I'm taking away the 12% as part of this calculation. And so if I do 146 million times by 0.88 or 0.88, I get 128,480,000. There we go. Research conducted for HMRC estimated that the cross-elasticity of demand for using game machines to be 1.28 in response to changes in the price of national lottery tickets. In October 2013, Camelot increased the price of a national lottery ticket from £1 to £2. Explain the likely impact of the increase of national lottery tickets on the demand for using game machines. Okay, so XED, percentage change in quantity demanded for a good labeled as A, can be whatever good you want, over percentage change in price of good B, again, can be whatever good you want. If you have a positive XED, that means that the goods are substitutes. The reason being is that if you have a percentage increase in the price of like PlayStations, for example, imagine that PlayStations and Xboxes are substitute goods. Like you don't care whether you play on Xbox or PlayStation, you just want to play video games. Well, if there's an increase in price of PlayStations, for example, then you're not going to buy as many PlayStations, but you may buy more Xboxes, which is why this good might be an Xbox and this one might be a PlayStation. Okay, so if I know that they are substitutes and we see here that Camelot increased the price of a national lottery ticket from £1 to £2. Explain the likely impact of the price increase of the national lottery tickets on the demand for using game machines. Well, the demand for using gaming machines will increase as lottery tickets and gaming machines are substitutes. Okay, and that's all we need to write. That's fine. Done. And then finally, for question 2, in 2016, a coastal flood defence scheme was completed at Broomhill Sands in Kent, protecting people, homes and businesses. A 30 million grant from the National Lottery paid for the scheme. The most likely reason for this grant is to ensure A, the exclusivity of Broomhill Sands. No. B, provision of a private good. No, it's not a private good. C, rivalry of Broomhill Sands. No, most likely is C, public good. Coastal flood defence schemes have the benefit of both being non-rivalrous and non-excludable, which makes them into a good known as a public good, commonly confused as being a good provided by the government. But in economics, we mean these 2 points. This is 1, this is 2. Okay, so done question 2. The average fee charged by high street estate agents to homeowners for selling property is 1.3% of the final sale price. Assuming the selling fee is 1.3%, calculate the payment received by an estate agent on a property sold for £489,000. You are advised to show your working. Okay, so the property fee sorry for my terrible spelling, is going to be 489,000. Okay, so that's the so the final sale price. Okay, so they've said the final sale price is 489,000. 1.3%. Okay, you can either do this as 1.3 over 100 to calculate it, or you can do it as 0.013. Either way, you get the same answer. So if I put that into my calculator, 489,000 times by 0.013, I get £6,357. That is a good day's work for a estate agent. Good payment, that. In August 2016, the Office for National Statistics reported that the average house price in London was £489,000, whereas in the northeast of England it was £127. The ratio of average house prices in London to the average house price in northeast of England is... Okay, so the ratio of average house price in London, 489,000, to the ratio of the average house price in this one is... Okay, so here we have the figure, and what we want to do is we want to calculate what that ratio is. Okay, so the ratio is going to be calculated by making it 1 to whatever that is. So it's most likely, if I do this to make it 1, if I need to make this 1, I have to divide it by 489,000. So this I need to divide by 489,000 as well. So if I do that, 127,000 divided by 489,000, I get 0.259 or 0.26. Okay, so that is the answer A. Explain one likely reason for the difference in average house prices between London and the northeast of England. Very good question, but hopefully it's quite intuitive what that is going to be. Part of the reason is going to be because of the fact that individuals in London are wealthier. They're higher paying jobs, which means that those individuals can afford to get larger mortgages, which drives up the price of houses in those areas. Okay, so one reason why house prices are higher in London than the North East is because of higher paying jobs in London, which there we go. Oops, excuse me. Zoom back in. Okay, more expensive houses as they can get larger mortgages. Okay, so mortgages are paid based on, well, firstly, the amount that you put down in deposit, but also the size of your income. So usually, typically, a mortgage is given and it will be, I don't know, approximately 4.5 times your annual salary. Ooh, here we go. Okay, so here, Emily owns and operates a nail ink salon. The diagram shows the cost and revenue curves for treatments at her nail ink salon. Initially, Emily sets her price to maximize profits. Okay, maximize profits. That is going to be where MR equals MC. Calculate the change in total supernormal profit if Emily changes her objective from profit maximization to revenue maximization. Okay, well, that is where MR equals 0. You advise, show you're working. All right, well, let's work out profit max first. Okay, so profit max is going to be where MR equals MC. So that is here. So they're selling 25 units. Okay, now in order to calculate the revenue, okay, I go up from this point all the way up to the AR curve, which is also the demand curve in this case, all the way up here, and then we go across here to 17. So in order to calculate the revenue, one part of my calculation is 25 times 17, which is 425. But remember that profit is TR minus TC, total revenue minus total cost. So I need to minus my total cost. So in order to do that, what I do is I go again from the 25 and I go all the way up to the bottom of the AC curve, or where this line intersects with the AC curve. And then I go across and I get 8. So the other calculation is 25 times 8, which I believe is 200, but just to double check, it is 200. Okay, so at profit maximization, it's going to be a profit of £225. Okay, so it's asking for the change in total supernormal profit. So first we need to, secondly, we need to work out the revenue max, which is going to be here, 36. So if I work out the revenue again, I go 36 and I go all the way up to the demand curve to this point, and I go across and I sell 12, which if I do 36 times 12, it gives me 36 times 12, 432. And then minus. Okay, so again, we need to figure out what the costs are. So we go up to the point where the costs are there, average cost curve, across to 9. So again, it's going to be 36 times by 9. 36 times by 9 gives you 324, which means that my answer is going to be, for revenue max, 432 minus 324 is 108. And so the difference between the two is equal to 425 minus 108. 425 minus 108, which is 425 minus 108, which is equal to £317 in difference. Look at that. You can see why firms want to profit maximize. Look how much more profit they make when they profit maximize. Wow, look at all the space we've been given. We don't need any of that space. Emily now decides to change her objective from revenue maximization to sales maximization. This change will lead to, okay, sales maximization is where AR equals AC. And so if we go up to our diagram, AR equals AC is this point here. So this is like Q3, and this is maybe P3. Okay, now remember that this is the profit max price, PMP. This is the revenue max price, RMP12, and this is the sales max price, SMP. So what we can see is that the price is lower, but they sell more of the product. So a decrease in the number of customers is wrong because the price is lower. A decrease in the price of treatments is potentially right? If we look at this, the price of treatments has gone down, but let's not just rule it out yet. An increase in productive efficiency. Well, no, that's not the case. And the reason why is because productive efficiency is at that point. We are previously revenue maximizing, which means that the distance is between these 2 points here. And then afterwards, it's the difference between these 2 points. So we're actually moving further away from that profit maximizing output. So no, we're not becoming more productively efficient. And also, no, we won't increase the level of profit. So B is the answer. The following graph shows the global sales of personal computers between 2011 and 2015. The percentage decrease in sales of PCs between 2011 and 2015 is, okay, percentage change, nice and straightforward. Percentage change in any value is equal to new minus old over old times 100. Okay, so what I'm looking for is 2015 and 2011. This is new and this is old. Okay, so if I do that, it's going to be 276.7 minus 352.4 over 352.4 multiplied by 100. Okay, so if I do 276.7 and I take away 352.4, then I would get minus 75.7. Divided that by 352.4 and then multiply by 100. Okay, so divide that by 352.4 gives me 0.21 minus 0.21 times 100, 21, minus 21.48, so minus 21.5. Oops. Okay, so minus 21.5, that's great. So it already tells us that it's decrease, so the answer is A. Explain one likely reason for the decrease in sales of personal computers. Hopefully, for most of you, this is relatively intuitive because you probably own like I don't know, an iPad or some other type of smartphone. You know, there are substitute goods available to PCs which are more convenient for most individuals, right? So that could be one likely reason. So one likely reason for the decrease in sales of PCs is that consumers prefer the ease of using tablets / smartphones which you can use anywhere rather than just at home. Okay, so there's been a growth of substitute products, of better substitutes. Very good. Okay. So this is the last question, because the next one is all about the energy market. So if we scroll up, we can see it says the following table shows global sales of PCs by company in 2015. Calculate the 5-firm concentration ratio you advise to show you're working. Okay, so the 5-firm concentration ratio is basically just the market share of the 5 largest firms, or the sales of the 5 largest firms divided by the total. So in this case, the easiest way to do this, 5-firm CR, is to do, so I could add all of these up, 1, 2, 3, 4. We could add all of these up if we wanted to, that's fine. And then divide it by the total. Or what we can do is take 276,700 minus 86,461, because, oops, you wouldn't want to add up this one, so ignore that, but you would want to add up all the others, because that tells us what the value is of these 5 relative to the total value. So if we do 276,700 minus 86,461, that will give us 190,239. Okay, then what I do is I take that 190,239 and I divide it by the total, which is 276,700, and then multiply by 100. 276,700 is equal to 0.687, and then you times by 100, and then I check if there's any requirements. Your advice to show you're working. Okay, I've shown my working, so I'm going to put it to 1 decimal place, which would be 68.8%. All right, thank you very much. That has been another Section A micro walkthrough. Hopefully this has been useful. Hopefully you found everything productive. The only one question that I am maybe not 100% confident on is this one, because my use of ratios, even though I think I'm right, is not always the best. So there's 2 options. It could either be that one, or it might be the other option will be that we do it the other way around. So we divide each one by 127. So if I do 489,000 divided by 127,000, I get 3.85. So the other option potentially is this. But we'll wait and see. I'll put in the comments if I've made an error of some sort. But yeah, hopefully this is useful. Hopefully you enjoyed it. Thank you very much for watching, and yeah, good luck. See you in the future.